welcome to the today's lecture. We have finished that prism theory and the dispersion of light. We have also done some numerical problems in that portion. And now let us today discuss the scattering of light. Scattering of light. देखो बेटा, जो स्कैटरिंग ऑफ लाइट है इसमें क्या होता है? हमें पता है कि लाइट जो है ट्रैवल्स इन ए स्ट्रेट लाइन. सपोज यहां पर हमारे पास एक सोर्स है, इस सोर्स से ये लाइट आती है. दिस लाइट ट्रैवल्स इन ए स्ट्रेट लाइन. नाउ when a light coming from the source passes through a medium, we can say such as air, this light interacts with the particles of medium. This light interacts or collides with the particles of medium through which it passes. When a light coming from the source passes through a medium, it interacts, it collides with the particles of a medium. Due to this incident light, this light coming from the source, it gets deflected. Means it changes its path. This phenomena by which the light is deflected from its path due to its interaction with the particles of a medium through which it passes, that phenomena is called as scattering of light. आपको पता है जो लाइट है, this travels in a straight line. When this light travels through a medium, जब ये मीडियम में चली जाती है, मीडियम में बड़े सारे पार्टिकल्स हैं. अगर हम आयर लेंगे, we have raindrops, we have dust particles. This light, it collides, it interacts with these dust particles, with these raindrops. As a result, this light, it changes its path, it gets deflected. This phenomena, according to which the light is deflected from its path due to its interaction with the particles of a medium through which it passes, this phenomena is called as scattering of light. Basically, ये जो scattering of light है, it's a two-step process. Scattering of light is a two-step process. पहले स्टेप पे क्या होता है? ये जो scattering particles हैं, these are called scattering particles. These scattering particles absorb the light falling on them. जो ये लाइट आती है, सनलाइट, ये स्कैटरिंग पार्टिकल्स पे पड़ती है. ये स्कैटरिंग पार्टिकल्स जो है ये लाइट क्या करते हैं? एब्जॉर्ब करते हैं. इन द फर्स्ट स्टेप, द स्कैटरिंग पार्टिकल्स एब्जॉर्ब द लाइट फॉलिंग ऑन देम. इन द सेकंड स्टेप, फर्स्ट स्टेप में क्या होता है? स्कैटरिंग पार्टिकल्स एब्जॉर्ब द लाइट फॉलिंग ऑन देम. सेकंड स्टेप जो होता है, सेकंड स्टेप में यही स्कैटरिंग पार्टिकल्स, ये एब्जॉर्ब्ड लाइट जो है, इस लाइट को ये री इमिट करते हैं इन डिफरेंट डायरेक्शंस. इन द सेकंड स्टेप, एब्जॉर्ब्ड स्कैटरिंग पार्टिकल्स री इमिट दिस absorbed light in different directions. लिहाजा सेकंड स्टेप में क्या काम करते हैं? जो ये एब्जॉर्ब्ड लाइट है, जो स्कैटरिंग पार्टिकल्स है, जो उन्होंने लाइट एब्जॉर्ब की, इस लाइट को ये मुख्तलिफ डायरेक्शंस में री इमिट करते हैं. एज अ रिजल्ट द लाइट गेट्स स्कैटर्ड इन डिफरेंट डायरेक्शंस. नाउ डिपेंडिंग अपॉन the size of these scattering particles, जो हमारी ये scattering है, it is of two types. Depending upon the size of these scattering particles, which absorb the light falling on them and then re-emit it, This scattering of light is of two types. Number one is called elastic scattering, or we can call it Rayleigh scattering. जो स्कैटरिंग है इट इज ऑफ टू टाइप्स. पहली स्कैटरिंग जो हम कहते हैं इसको कहते हैं हम इलास्टिक स्कैटरिंग और रेले स्कैटरिंग. इलास्टिक स्कैटरिंग जो है इट इज दैट टाइप ऑफ स्कैटरिंग जिसमें ये जो स्कैटर्ड लाइट है, दिस इज द स्कैटर्ड लाइट, दिस इज द स्कैटर्ड लाइट. इस स्कैटर्ड लाइट की फ्रीक्वेंसी या इस स्कैटर्ड लाइट की वेवलेंथ सेम होती है एज दैट ऑफ इंसिडेंट लाइट. हम ऐसे कहेंगे द टाइप ऑफ स्कैटरिंग इन विच द वेवलेंथ और द फ्रीक्वेंसी of the scattered light is same as that of the incident light. That type of scattering is called as elastic scattering or Rayleigh scattering. It means that during such type of scattering there is no change in the frequency of the incident light. Collision, जब collide करेंगे, जब incident light collide करेगी scattering particles से, इस collision में जो इंसिडेंट लाइट है इसकी वेवलेंथ चेंज नहीं होती है, क्योंकि आफ्टर कोलिजन द इंसिडेंट लाइट विल अपीयर एज अ स्कैटर्ड लाइट. सिंस द स्कैटर्ड लाइट हैज सेम वेवलेंथ एज दैट ऑफ द इंसिडेंट लाइट, इट मींस दैट ड्यूरिंग सच टाइप ऑफ कोलिजन देयर विल बी नो चेंज इन द वेवलेंथ ऑफ द इंसिडेंट लाइट. सच टाइप ऑफ स्कैटरिंग इज कॉल्ड एज इलास्टिक स्कैटरिंग. तो इलास्टिक स्कैटरिंग में क्या होता है, फ्रीक्वेंसी और वेवलेंथ of scattered light is same as that of incident light. Now, ये कब होगा? It occurs when size of scattering particles is very small as compared to the wavelength of incident light. Is very small as compared to the wavelength of incident light. This इलास्टिक स्कैटरिंग occurs only जब जो स्कैटरिंग पार्टिकल्स होंगे उनका जो साइज होगा दैट विल बी वेरी स्मॉल एज कंपेयर टू व्हाट वेवलेंथ ऑफ इंसिडेंट लाइट, सो दैट देयर इज नो एक्सचेंज ऑफ एनर्जी, देयर इज नो एक्सचेंज ऑफ एनर्जी बिटवीन द इंसिडेंट लाइट and the scattering particles. तो मैंने यहां लिखा जो ये रेले स्कैटरिंग है या इलास्टिक स्कैटरिंग है ये तब ओकर होती है जब साइज ऑफ स्कैटरिंग पार्टिकल बहुत छोटा होगा एज कंपेयर टू वेवलेंथ ऑफ इंसिडेंट लाइट, so that there is no exchange of energy, no energy is transferred between the incident light and the scattering particles. This was about elastic or Rayleigh scattering. Now let us discuss the second type, that is inelastic scattering, or we can call it Raman scattering. The second type is inelastic scattering, or we can say it Raman scattering. जो दूसरी टाइप है स्कैटरिंग की उसको हम कहते हैं inelastic scattering और Raman scattering. This is opposite to that of elastic scattering. Elastic scattering में scattered light की frequency, scattered light की wavelength same थी as that of the incident light, लेकिन यहां सेम नहीं है. Here, the frequency or the wavelength of the scattered light is different from that of the incident light. Probably it is less than that of the incident light. तो यहां पर क्या होता है inelastic scattering में? Frequency or wavelength of scattered light is different from that of incident light. It means that during such type of scattering, there occurs change in wavelength, there occurs change in frequency of the incident light. Such type of scattering is called as inelastic or Raman scattering. We can say that the type of scattering in which the wavelength or the frequency of the scattered light, it is different from that of the incident light. This type of scattering occurs when the size of scattering particles is very large as compared to the wavelength of incident light. ये जो रमन स्कैटरिंग है या इनइलास्टिक स्कैटरिंग है, ये तब होकर होती है जब वेवलेंथ ऑफ स्कैटर, जब साइज ऑफ स्कैटरिंग पार्टिकल्स जो है, जो स्कैटरिंग पार्टिकल्स है जिनके साथ लाइट्स कोलाइड करते हैं, इंटरेक्ट करते हैं, इनका साइज जो होगा इट विल बी लार्ज एज कंपेयर्ड टू वेवलेंथ ऑफ इंसिडेंट लाइट, सो दैट देयर occurs exchange of energy between the incident light and the scattering particles, SP scattering particles. Such type of scattering is inelastic or Raman scattering. So in Raman scattering, the size of scattering particles is very large as compared to the wavelength of incident light, so that there occurs exchange of energy between incident light and scattering particles. This completes the types of scattering. We will discuss now an important law in the scattering of light. That law is called as Rayleigh Scattering Law. Rayleigh Scattering Law. Rayleigh Scattering Law. Rayleigh Scattering Law. Very important law. With the help of this law, we can explain some beautiful optical phenomena. With the help of this Rayleigh Scattering Law, we'll be able to explain some beautiful phenomena occurring in nature. What is this light? This is scattered light. This is what light? Incident light. Suppose the wavelength of this incident light is lambda. We have read earlier that in case of Rayleigh scattering, the size of scattering particles is very small as compared to wavelength of incident light. According to this law, the intensity of this scattered light, I, is inversely proportional to the fourth power of wavelength of incident light. जो रेले स्कैटरिंग लॉ है, ये क्या कहता है? जो स्कैटर्ड लाइट है, इसकी जो इंटेंसिटी है, वो इंटेंसिटी जो है, that is inversely proportional to the fourth power of wavelength of incident light. यानी I is inversely proportional to lambda raised to power 4, where lambda is wavelength of incident light. Provided, यहाँ कंडीशन दी गई है, the size of scattering particles, provided the size of scattering particles is very small as compared to wavelength of incident light, as compared to wavelength of incident light, as compared to wavelength of incident light. क्या कहता है? The intensity of the scattered light is inversely proportional to the fourth power of wavelength of the scattered light. That is, I is inversely proportional to lambda raised to power 4. Provided, condition दी गई है, size of scattering particles is very small as compared to wavelength of incident light. हम लोगों को पता है जो white light है, white light consists of 7 different colors. 7 different colors. What are these colors? These colors are, उनको हम ऐसे याद रखेंगे, VIB, VIB, GYOR. This violet color जो होता है, this has shortest wavelength, and this red color has longest wavelength. These are the 7 colors in the spectrum of sunlight. सबसे ज्यादा वेवलेंथ जो होती है वो रेड कलर को होती है, सबसे कम वेवलेंथ जो है वायलेट कलर को होती है. नाउ इस रेले स्कैटरिंग लॉ से हम ये एक्सप्लेन कर सकते हैं कि जो ये व्हाइट लाइट है, इस व्हाइट लाइट में जो 7 कलर्स है जिनकी 7 डिफरेंट वेवलेंथ्स है, these 7 colors will get scattered by different amounts. Since I is inversely proportional to lambda raised to power 4, it means that the scattering intensity of the different colors present in the sunlight will be different. Some color present in the white light will get more scattered. Some color present in the white light will get least scattered. Smaller the wavelength, larger will be the scattering intensity. It means a light having smaller wavelength will get more scattered than a light having larger wavelength. A light having larger wavelength will have lesser scattering intensity because there is an inverse relation. Lesser scattering intensity means the light gets least scattered. Since violet color has smaller short wavelength as compared to what color? Red color. Therefore, the scattering intensity of violet color will be more as compared to that of what color? Red color. Therefore, we can say red color scatters least, whereas violet color scatters most. Red color scatters least due to its what? Long wavelength, whereas violet color scatters most due to its short wavelength. Now, with the help of this Rayleigh scattering law, we will be able to explain some of the beautiful phenomena in optics. The first beautiful phenomena you have read in class 10th, I will repeat here, that is why the color of the sky is blue. Why the color of sky is blue. Why the color of sky is blue. हम एक्सप्लेन करेंगे जो हमारा कलर है उसका, जो हमारा स्काई है उसका कलर जो है, why the color of sky is blue, why it is not black, why it is not red, why it is not green. So the first phenomena which we explain on the basis of Rayleigh scattering law, that is blue color of sky. Blue color of sky. Why sky appears blue? See, as per Rayleigh scattering law, the intensity of the scattered light, that is inversely proportional to the fourth power of wavelength of the incident light. Light having smaller wavelength will get more scattered than the light having longer wavelength, that gets least scattered. Now, the light coming from the sun has to pass through the atmosphere. Therefore, while traveling while traveling through the atmosphere, this light collides with the atmospheric molecules. When it collides with the atmospheric molecules, this light gets scattered. Since this sunlight is made up of 7 different colors, therefore these 7 different colors will suffer 7 different types of scatterings. These will suffer. Some colors will suffer less scattering, some colors will suffer more scattering. For example, red color suffers least scattering, whereas the violet color suffers most scattering. Some colors get scattered by more amount, and some get scattered by least amount. Now, wavelength of blue color is less than wavelength of red color. Wavelength of blue color is less than wavelength of red color. Therefore, as per this law, the scattering intensity of blue color will be greater than the scattering intensity of the red color. It means that blue color gets more scattered than what color? Red color. Hence, the color of the sky appears blue. Because if we look everywhere, we see blue color. It is because the scattering of the blue color, the scattering intensity of the blue color is greater than the scattering intensity of the red color, because the wavelength of blue color is less than the wavelength of the red color. Smaller the wavelength, greater is the scattering intensity as per the Rayleigh Scattering Law. Now, why blue? Why not violet? Why not indigo? These violet and indigo colors, they are insensitive colors. They are not sensitive to the human eye. So therefore, we omit these two colors. We say that the sky, we take only what color? Blue color. So our eyes can more be sensitive to blue color than to the violet or the indigo color. Hence, this sky, it appears blue. Now, since I have told you that blue color of the sky is due to the scattering of sunlight by the atmospheric molecules. Now, if there had been no atmosphere, अगर atmosphere मौजूद नहीं होगा, then the scattering of light will not take place, because there will be no scattering particles. If there had been no atmosphere, when there is no atmosphere, there are no scattering particles. When there are no scattering particles, there is no scattering of light. In that case, light जो है, जो white light, ये सीधे नीचे आ जाएगी. अगर आप ऊपर देखेंगे sky की तरफ, that will appear black in color. In the absence of atmosphere, the sky, it doesn't appear blue, it appears black, because there will be no scattering of light. Because due to scattering of light, the colors present in the sunlight will suffer different type of this scattering. Some suffer more scattering, some suffer least scattering. But when there is no scattering, the light comes down straight. So in that case, if we look upon the sky appears black. So in the absence of atmosphere, our sky appears black. Because in the absence of atmosphere, there are no scattering particles. When there are no scattering particles, there is no scattering of light. Now the third one, third phenomena. Danger signals, all of you know that danger signals are red in color. Danger signals are red in color. आप लोग जहां भी देखेंगे, जहां भी डेंजर होगा, तो वहां कलर जो होता है वो रेड कलर होता है. अगर आप ट्रांसफार्मर देखेंगे, जो गांव में ट्रांसफार्मर होता है, वहां रेड कलर का बोर्ड लगा होता है. अगर आप ट्रैफिक जाम में जाओगे, कहीं ट्रैफिक देखोगे, ट्रैफिक सिग्नल्स देखोगे, तो वहां दो किस्म की बत्तियां आती है, ग्रीन कलर और रेड कलर. जैसे रेड कलर चढ़ता है, हर एक गाड़ी जो है वो स्टॉप होती है. क्यों स्टॉप होती है? रेड कलर इंडिकेट्स डेंजर. रेड कलर इंडिकेट्स डेंजर. आज मैं बताऊंगा क्यों. डेंजर सिग्नल्स जो होते हैं, These danger signals should be made of the color which is least scattered so that they can be seen from a distance. Danger signals जो है वो उस कलर की बनी हुई होती है जिस कलर को लीस्ट स्कैटरिंग हुई होगी, जो तो कलर फैला नहीं होगा, जो एक ही जगह चिपका होगा, so that they can be seen from a distance. Danger signals must be made up of a color which is least scattered, so that they can be seen from a distance. दूर से हमें वो नजर आनी चाहिए. चूंकि रेड कलर जो है इसकी larger wavelength है, longer wavelength है. Due to longer wavelength, red color scatters least. Hence, it can be seen from a distance because it scatters least. Hence, it can be seen from a distance. As a result of this, these danger signals are red in color. हम ऐसे बताएंगे, danger signals are red in color because red color scatters least because of its larger wavelength. Therefore, this red color can be seen from a large distance. Hence, these danger signals are red in color. Next phenomena. सुना होगा बच्चों आपने? Why are clouds white in color? Why are clouds white in color? Clouds जो होते हैं, they are white in color. That is discussed. हमने पढ़ा why sky is blue in color, why danger signals are red in color. Now let us discuss why clouds are white in color. देखो बेटा, जो clouds होते हैं, clouds में जो स्कैटरिंग पार्टिकल्स होते हैं, कौन कौन स्कैटरिंग, क्या क्या स्कैटरिंग पार्टिकल्स क्लाउड्स में होते हैं? रेन ड्रॉप्स, डस्ट पार्टिकल्स एटसेट्रा, डस्ट पार्टिकल्स एटसेट्रा. क्लाउड्स में जो स्कैटरिंग पार्टिकल्स होते हैं, जैसे कि रेन ड्रॉप्स, जैसे कि डस्ट पार्टिकल्स, इनका साइज जो होता है दैट इज लार्जर एज कंपेयर्ड टू द वेवलेंथ ऑफ द इंसिडेंट लाइट. The scattering particles present in the clouds, the particles present in the clouds, such as raindrops, dust particles, their size is very large as compared to wavelength of light. Therefore, these dust particles, these raindrops present in the clouds, they do not scatter the light as per Rayleigh scattering law, where different colors suffer different scattering. क्योंकि जो क्लाउड्स में स्कैटरिंग पार्टिकल्स होते हैं, जो क्लाउड्स में पार्टिकल्स होते हैं, रेन ड्रॉप्स होते हैं, डस्ट पार्टिकल्स होते हैं, इनका साइज जो होता है वो ज्यादा होता है एज कंपेयर टू द वेवलेंथ ऑफ द इंसिडेंट लाइट. लिहाजा जो स्कैटरिंग पार्टिकल्स, जो ये पार्टिकल्स क्लाउड्स में होते हैं, ये लाइट को स्कैटर करते हैं, बट नॉट एज अकॉर्डिंग टू द रेले स्कैटरिंग लॉ, जहां जिसमें डिफरेंट कलर्स जो होते हैं व्हाइट लाइट के, वो दैट दे सफर डिफरेंट अमाउंट ऑफ स्कैटरिंग. हाउएवर, these scattering particles, they scatter light equally in all directions. जितना ब्लू कलर एक डायरेक्शन में उन्होंने स्कैटर किया, उतना ही रेड को भी करेंगे, उतना ही ग्रीन को भी करेंगे, उतना ही इंडिगो को भी करेंगे, उतना ही ऑरेंज को करेंगे. जितना ये दूसरी डायरेक्शन में रेड कलर को स्कैटर करेंगे, उतना ही ब्लू कलर को, उतना ही ऑरेंज कलर को, उतना ही येलो कलर को, उतना ही इंडिगो कलर को. इसका मतलब है these particles present in the clouds, they scatter light equally in all directions. As a result of this, the light, the scattered light, that also appears white. Hence, these clouds are white in color. These are white in color. समझ आई बात? One more phenomena you are observing in everyday life: reddish color of sun at the time of sunset and sunrise. Sunset and sunrise. एक और फिनोमेना जो है that is reddish color of sun at the time of sunset and sunrise. अब लोगों को पता है जब सनराइज होता है या सनसेट होता है, जो हमारा सन है that appears reddish in color. हम एक्सप्लेन करेंगे क्यों होगा सन reddish in color at the time of sunset and sunrise. This reddish color of sun at the time of sunset or at the time of sunrise is due to the scattering of sunlight. देखो कैसे, सपोज ये हमारा अर्थ है, यहां पर जो हमारा ऑब्जर्वर बैठा है, देखो बच्चों, at the time of sunset or sunrise जो मेरा सन है, this sun is at the horizon. ये horizon पे होता है at the time of sunset और sunrise. जो हमारा सन है, it is where at horizon. नोन पे ये डायरेक्टली होता है above the head of a observer. ऐसे जो 12 बजे नोन टाइम होता है, उस वक्त जो हमारा सन होता है, इट इज डायरेक्टली above the head of the observer. देखो बच्चों, at the time of sunset or sunrise the sun is at the horizon. Therefore these sun rays have to travel larger distance to reach the eye of the observer, than at the noon. सनसेट और सनराइज के टाइम जो आपका सन है वो हॉरिजन पे है, लिहाजा जो सनलाइट रेज ऑफ लाइट आते हैं सन में, उनको ऑब्जर्वर तक पहुंचने के लिए लार्ज डिस्टेंस कवर करनी पड़ती है. देन एट नोन पे कम डिस्टेंस करनी पड़ती है. ठीक है, ड्यू टू दिस क्या होगा, चूंकि जो सन रेज है दे हैव टू ट्रेवल लार्ज डिस्टेंस to reach the eye of the observer at the time of sunset or sunrise. Since the blue color has shortest wavelength, has smaller wavelength, therefore while traveling through the atmosphere to reach the observer, this blue color present in the sunlight gets completely scattered. क्योंकि डिस्टेंस बहुत कवर करनी है, तो लिहाजा ब्लू कलर जो है, उसकी वेवलेंथ स्मॉल होती है, लिहाजा वो ब्लू कलर जो सनलाइट में है दैट गेट्स कंप्लीटली स्कैटर्ड. लिहाजा जो रेज ऑफ लाइट अब सन से आई ऑफ द ऑब्जर्वर तक पहुंचेगी, उनका कलर क्या होगा, रेड. वाई रेड? बिकॉज रेड इज लीस्ट स्कैटर्ड ड्यू टू इट्स लॉन्गर वेव लेंथ. हम ऐसे बोलेंगे, at the time of sunset and sunrise the sun is at the horizon, therefore the rays of light has to travel larger distance to reach the eye of the observer than at the noon. Due to this, the blue color present in the sunlight gets almost completely scattered due to its short wave length. As a result, the rays of light reaching the eye of the observer will be red in color due to their least scattering. Hence, sun appears reddish in color at the time of sunset and sunrise. This completes scattering of light.